I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Algebra Unit 5, Lesson 4. We're going to be talking about writing systems and then interpreting the solutions to the system. So when we're writing a system, we want to be sure to identify our variables because this will help us interpret the solutions. And this is very similar to when we wrote linear equations, except this time we have two linear equations and we're trying to figure out if they intersect. And if they intersect, we want to know what is the intersection and then what does that mean for the problem. So the first problem says that one high-speed internet provider has a $50 setup fee and costs $30 per month. Another provider has no setup fee and costs $40 per month. The question is asking, in how many months will both providers cost the same, and what is that cost? So I'm going to write my equations, but before I do, I'm going to identify what my x and my y is. And this x and y needs to be the same in both equations as far as what it represents. So I know that I have a cost somewhere, but I also know that I'm paying per month. And so my months is going to be my independent variable, my x. And the cost will depend on how many months I have internet. So that is my x and my y for both equations. So now I need to write my two equations. So the first equation is the cost is equal to $50 for them to set it up plus the $30 per month, which is the 30x. The second company has no setup fee, so it's just y equals 40x. There's no y-intercept, there's no setup fee. It's just $40 per month. So I need to solve to see, again, the point of intersection if there is one. Notice that both of these equations are in y equals. So I could graph them. These numbers are kind of large though, and I don't really want to have to deal with that on a graph. So I'm going to substitute the 50 plus 30x in for the y, and so that is going to equal 40x. I'm going to subtract the 30x on both sides. So now 50 equals 10x, divide by 10, x equals 5. So if x equals 5, I can then plug that into either equation. I'm going to plug it into the first equation, 30 times 5, y equals 50, plus 30 times 5 is 150, y equals 200. So the solution is 5, 200, which means at 5 months, both providers will cost $200. Now, again, there's only one solution. So if these were graphed on a graph, we would see them intersect at this point right here, but then at every other point, they would be different. And so you have to think about that one of these is going to be cheaper at certain points. So which provider is cheaper? Okay, well, at 5, they're the same, so there's no argument there. But what about at 3 months, which is cheaper? Well, how do I figure that out? By plugging in a 3 for x. So I'm just going to do this mentally. If I plug in a 3 for x in the first equation, 3 times 30 is 90, plus 50 is 140. So at 3 months, it would be 140 for the first provider. And for the second provider, 3 times 40 is 120. Okay, so this is provider A and this is provider B, and this is the number of months. So at 3 months, B is cheaper, but what about at 6 months? We know what happens at 5, they're the same. At 6 months, 6 times 30, is 180. 180 plus 50 is 230. 6 times 40 is 240. So you see it switches. So after the solution, the equations then, one of them that was the one that was cheaper is now more expensive, and the one that was more expensive is now cheaper. So this is a very applicable skill that you need to know how to do when you're comparing two products or you're comparing two services, you're trying to plan a trip, anything like that. It's important to be able to compare these things the right way so that you know which is the better option for you. Let's look at one more problem. Bowl-O-Rama charges $2.50 per game plus $2 for shoe rental, and Bowling Pins charges $2 per game plus $4 for shoe rental. For how many games will the cost be the same, and what is that cost? So again, I need to identify what is my X and what is my Y. Again, I have a cost that I'm dealing with. The independent variable, so what does the cost depend on? It doesn't depend on the shoes. The shoes is a fixed cost. The cost will depend on the number of games we play. And again, the cost depends on that. So that is Y. So now I need an equation for Bowl-O-Rama, and I need an equation for bowling pins. So Bowl-O-Rama is $2.50 per game. Game is X, plus the $2 shoe rental. Bowling pins is $2 per game, plus the $4 shoe rental. Again, the shoe rental is our y-intercept. Okay, hypothetically, if we go to the bowling place and we don't bowl a game, we still have to buy the shoes. All right. So again, notice that the y is by itself. So I can just substitute this in for this y. So 2x plus 4 equals 250x plus 2. So I'm going to subtract my 2x on both sides. 4 equals 0.50x plus 2. Subtract the 2. 2 equals 0.50x. Divide by 0.50. Now, when you divide by a number less than 1, you actually come out with a larger number. 2 divided by 0.5 is 4. So x equals 4. What is x? X is the number of games. So the cost will be the same when playing 4 games. Now we need to figure out what the cost is going to be. So again, I can plug it into either equation. So I'm going to plug in this 4 for this x here just because it looks like an easier equation to me. So 2 times 4 plus 4 equals y. 8 plus 4 equals y. 12 equals y. So the cost is $12. So when I play 4 games, at either place, it's going to cost me $12. So again, which one is going to be cheaper if I only want to play 3 games? Okay, if I only want to play 3 games, in the first one, 250 times 3 is 750 plus 2 is 950. Okay, so I'm going to do this down here. So Bowl-O-Rama is going to be, so it's 250, and I said I wanted to figure out what happens at 3 games, plus 2. That is equal to 950. And bowling pins is going to be 2 times 3 plus 4, which is 6 plus 4 is 10. So Bowl-O-Rama is cheaper at 3 games. Okay, what happens at 5 games? Well, again, it will flip. So at 3 games, Bowl-O-Rama is cheaper, but at 5 games, bowling pins will be cheaper. So bowling pins is cheaper for 5 games or more. Anything above 5 games is going to be cheaper to go to bowling pins. And think about why that's the case. That's the case because the price per game at bowling pins is cheaper. So if I'm not playing a lot of games, then Bowl-O-Rama is better because the shoes are cheaper. But if I'm going to be playing a whole lot of games, it's cheaper to go up by 2 every time than to go up by 250 every time once I get past that break point. Okay, so that's how you set up a system from a word problem and then be able to interpret the solution.
I've been waiting way too long.